from this diagram I've got the lengths of each section of the box section where I need to make the pie cuts here, here and here. I've worked out the angle because I know how wide the box section is. I know how big a gap there should be at the end of the triangle that I've got to cut out. So 8.3, 6.9 and 9.89 millimeters. So I've measured that out on my steel bar. So like, where are we? Here's one pie cut. There, I've measured it where I've got a cut. And the same with that one. And the same with that one. So in theory, if I cut these and then just bend the tube, so I'll cut on three sides, there, there and there, cutting a V shape. As I bend it together, it should match my full scale pattern here. I'm using this piece of aluminium strip as a guide, just clamped it on. It just gives me the first cut, just very shallow like this, just to mark it so it's in the right place, rather than just doing it by eye. And I'm using one of these diamond tipped saws that are guaranteed for 3,000 cuts. So well, we'll see. I probably won't be counting, but it should last the whole of this project if that's true. So I've done the same here. So I've done the other side, done the vertical, just got this left to do. So I've just laid this out on my pattern, and if we start with this one here, I've just tack welded a bar from there across to there, just using a cheap MIG welder, just to hold it exactly at the right angle while I TIG weld it together. Okay, so I've been using a TIG welder now to do this. They're reasonably neat welds, and I've also gone for a stronger support strut because the other one bent slightly as the weld shrank. So coming along slowly, you can see that plus or minus 3 or 4 millimeters I'm actually following the original pattern. Well, this second one is faster because I can use the first one as a template. So you can see I've just got some tack welds there. The ends pretty well match up. I actually redid one of the welds because I wasn't happy with it, but you can see this end, they're perfectly matched, and then all the way along pretty darn good. And then this end about 4 mil out. This one was actually lower, it was about here, so I've improved it. That's probably, to be honest, that's probably as good as it's going to get in terms of perfect symmetry. Right, I laid these two halves out on my full-sized cardboard template and got everything perfectly lined up, and then I put these little screws in to my homemade platform here with little markings, and same the other side to hold it exactly in the right place. And then I G-clamped these two cross members on, and I've just used the MIG welder to zap away, fix them on. Eventually these will be cut off. These hold the sides in exactly the correct position, so they're not going to go anywhere while I build everything up. So the next thing to think about is the front suspension. So this here has an internal width of 2 inches, which is exactly the same as this spring. So I'm going to use it as a spring channel with the spring sitting up inside it, and then big clamps holding it. So it's going to run across here, but the problem is, what height do I mount it? So I've been doing tons of calculating and measuring with my diagrams. These are standard 28-inch wheels at the front. I put a ruler between here and the ground, and then jumped up and down on this to work out how much this would go down in compression. It's about 1 inch, so I need to think about the main weight will be me towards the front and the engine towards the back. So if I put my whole weight on top of that and it goes down 1 inch, then I can roughly calculate, I can allow for that as well. So turns out I'm going to need a triangular bit here that it mounts to, and it needs to be about 14 centimeters up, because my spring is running over the top of the axle. In some designs, and I can't remember what years, you'll see that the spring is in front of the axle and lower down. These spring hangers down here, just in front, which means you'd have a lower spring. But anyway, that's a fairly traditional layout. So springs on the top, which means the spring's got to be kind of running across over here somehow. So I'm probably going to mock it up in some plywood to begin with, but I need some triangular pieces here about 14 centimeters high with this will be cut into like a U channel, and that will then weld onto the front. Also, you need a little bit of lean back. I've calculated that my chassis rails here aren't going to be parallel with the ground. The rear is going to be slightly up because I'm going to have 31-inch tyres at the back. So I've done the maths on that, and it will be about 2.5 degrees, 2.4 degrees forwards, like that. But the kingpins need to be angled about 5 degrees back. So basically my little wedge here needs to be, relative to this, needs to be angled back about 7.4 degrees, so it'll be sort of like that, along and down, something like that, mounting bracket. But I'm just going to mock it up first in with a bit of wood, just to see how it would turn out. Right, my next problem is if I weld in a piece of U-shaped channel across here with the spring coming up through it. By the way, I've cut these off the correct place now. If I weld it across here, you've got to remember that the bodywork is kind of like a circle here, and it's tapering in, it's quite small. So here's 1/2 of it, it's the outer line there. So what I need to do is get a compass, or measure from there to there, and then draw out a circle with a big compass. Now, this is a bit different to the one you had in school. This is like the world's biggest compass. It's actually great. Got this is about £12 from a well-known website, and I'll cut out a circle and strap it to the front here with tape, and then I can work out what the maximum width of my channel here that's going to carry my spring can be before it starts sticking out through the bodywork. Obviously the spring will kind of come down here and that'll poke out through the bodywork, but you don't want the bracketry to show, ideally, or you know, maybe just the ends of it slightly, but ideally not, just the spring coming out through 2 little holes. Right, so I've cut out my circle. So that's how the body, that's the diameter of the body at this point. So what's this telling me? Well, I know the top of my bracket is going to be ideally 14 centimeters above this tube, and what I want to know is if I just make a spacer here and then put the channel all the way across here, will it poke out through the sides of the body? So that would represent the top of the channel, which should be running like that all the way across here, 14 centimeters up. So the answer is, yeah, I can just weld a piece straight across with a spacer on a bracket and it won't stick out through the bodywork. Only the spring will stick out through the bodywork about here somewhere as it comes down. So that just helps me relax when I'm building this. I weld the whole thing together and then find out it's poking through the body. That would be a bit of a disaster. So here I've done an amazing bit of artwork to represent how this is going to fit on here. So just get my head around it really. So here's the ends of my box section here and here. You can have vertical bracket, whole thing tipped back 5 degrees. Spring will be something like that. it'll sit inside this channel here, which is U-shaped, and then you'll have the big U-bolts here and a plate here clamping the whole thing up. Right, I'll just show you what I'm doing here. This took a lot of, sorry about the noise, grinding and hacking and whatever to get it right, but it's worth doing because it exactly fits the spring leaves, you see, exactly right. So that will go there and the spring leaves will sit inside there, so then I can weld this onto here. So you can see how this is going. Let's put that down. So these have been individually cut, just tack welded on at the minute, and one there, and then we can put a plate. Put a plate there, like that, and then weld this in there, like that. You see. And then I'll plate all down here and down here, so it's nothing can get in, salt water and stuff can't get in, and it should be really strong and it should take the weight. The spring will then sit in here, across here like that. Whole weight of the car will be on this, which is why I'm making it so strong. Okay, I'm filming this about 4 hours later than the last clip. So you can see this is in, these are welded in, all the welded up on the inside. I've just got these to finish off on the outside, and then I've plated down here and I've plated here under the front up to here, and it's all smooth, so my spring should slot in there. I should have 2 clamps there and there, and the spring should come down like this, which means it should just clear this nicely. Yeah, so a lot of work, but pretty pleased with that. Okay, I've got this stud lined up with the hole that I made, so now I've got to just use this clamp to just carefully bring it in. Will it come through the hole or will it get stuck? It's slightly stuck. Okay. A little bit of hammering got it into the centre, and then I did up the clamp and it's come through the hole and seated. I smeared the whole of this channel with grease, so it'll be, you know, well lubricated as the spring moves up and down. So the next thing I need to do is make clamps, 2 clamps that go over here, the not U-bolts, flat-headed U-bolts if you like, and a plate under here which gets bolted up. I can't use the standard plate because the width here is now greater than the spring by about 10 mil. This is 5 mil thick steel, so I found the correct size. They're actually a Land Rover part. I think they're Land Rover or Range Rover, but I mean the thread's way too long. I'll need to cut the thread down, but actually they fit bang on. Actually the thread runs up just enough. If I have a plate here I don't run out of thread, and obviously this will be cut down, and these are, you know, designed for loads that weigh in excess of what this Ford front axle will ever experience. Right, I'm in the process of making this plate that these will bolt through. My drill bits don't actually go up to this size, they're pretty big holes, so use the largest I had, and then I actually just reamed them out with these little tungsten bits with a Dremel. So here all I've done is I've welded 2 two pieces together of this bar, and then you put a strengthening piece across the top, so they'll actually come in from below like that, and this will be on the underside. Okay, but that should have fit. I just need to round off these edges and make it look nice. Here it is, all bolted in. You've got to make a hole in the middle of the plate as well, because of course there's a nut on the end of that thin bolt that runs through there. So I'm thinking of putting my shock absorbers, lever shock absorbers here, with the arms sticking out, and then going down to some variation on the standard aftermarket shock absorber bracket that you can get. So I've got the rear end jacked up to what I think is the correct angle, and you can see I've got one of these little magnetic gauges here. The lean back of my kingpins here, the back lean is 5 degrees, which is what I calculated it should be. And then if we put it on there, just let it settle, my calculations were, if I have 28-inch front tyres, 31-inch rear tyres, that I would have a 2.5 degree front tilt on the actual frame, and you can see I've pretty much got that to about 2.5 degrees. And the other thing that's useful is, which is always a good sign, these are parallel to the ground in this position, which is kind of what you'd expect them to be, and also my rod ends here will go into a bracket on the frame, but you can see I can actually tuck it under the frame just a little bit like that. And you might say, well, what difference does that make? It just helps a little bit with the turning circle, because with this particular type of axle, I think in an earlier video I talked about them, you can get different axles, different widths, but also the widths between the spring perches are different. So it's this distance here that's important in terms of whether the wheel hits this. So it affects your turning circle. So if this was more inboard, I'd get a slightly better turning circle, or if the whole axle was wider and these stayed where they were. But anyway, this is what I'm using. Of course, it doesn't really matter if my turning circle is a bit rubbish, because this car's meant to pretty much go straight most of the time. So I've got these lever shock absorbers fixed to my rear suspension, but of course I'm not going to be using them at the rear, because the rear is going to be solid. It comes with 2 tabs to bolt down into something, so I could put something, piece of box section kind of here with it bolted down into the top. That would keep it within the confines of the bodywork, with the arm sticking out here and then a rod going down to here. Or I could go lower. The travel on this is only about 1 inch, so I could bring a piece of, weld piece of metal on here, bar coming out to about here, with it mounted on there, and then the lever, and then a short link down. So I think the thing to do, which would be quite cool, it'd be perhaps more aerodynamic, although if they stick out here and go down, you can drill holes in them and make them look quite funky and cool. But yeah, I might go for this. I think the thing to do is literally do that last. We'll make the bodywork first, then worry about whether you're going to put the shock absorbers here or kind of there, and how far inboard or you want them. So I think that's going to be one of the last things I do, actually, is build the shock absorber, put shock absorber mounts.